Hello and welcome to the Intro to Machine Learning course. In this course, we'll be talking about machine learning and eventually we'll get into complex neural networks and talk about deep learning. What is machine learning? Machine learning is training a model on some data and getting output. When you train this model and you can supply it with more data and get your desired output. That's basically machine learning, training a model without giving it specific instructions. There are two types of machine learning. One is supervised learning and the second is unsupervised learning. Supervised learning is when you have a model that you have instructed to classify data. Let's say I have t-shirt sales and I have on one axis I have the price and the second axis I have the cotton percentage. So I can predict if will it be a top seller or not a top seller. That's supervised learning because I'm telling the model to classify it to just classify it. Unsupervised learning is when you just give the model data and tell it to find patterns in the data. Let's say I give the same t-shirt sales data to it and now the model will try and predict which t-shirts sell more and sell less. Now these examples may look similar, but they are a little different. So when you are doing unsupervised learning, you're not telling the model what to do, what to find. In supervised learning, you are telling the model specifically what to find. You're giving it, so you're not giving it specific instructions, but you are telling it what to find. These are some machine learning applications that we can see in our daily life. So ChatGPT, it's a machine learning application. YouTube's recommending system. So let's say you watch a video on coding, then the next video will probably be from another coding channel. Banking, there's fraud detection systems, there's stock bots, stock trading bots. So that's all machine learning. Tesla, so self-driving cars, again machine learning. Amazon Alexa, again voice recognition, that's machine learning. Image recognition, that's again machine learning. So everywhere in the world now, you'll probably see machine learning. So we know that machine learning means to teach a machine. But how do we teach a machine? We teach a machine using a neural network. So a neural network is actually inspired by our brain. So our brain has things called neurons, are neurons that transmit signals to the brain and from the brain. So in the same way, we build out neural networks. We can have many layers with many types of neurons, and these neurons have parameters or numbers that are adjusted to get data. Now some things to remember about neural networks is that everything is a number and what the numbers are adjusted to train the model. Also, there can be many layers. So to build a neural network, we either use PyTorch or TensorFlow, which are two of the most popular libraries. However, there are more libraries which you can use. So the prerequisites for this course is Python. So you need to have basic knowledge of Python, not any libraries, just basic Python. You need to know like things like functions, variables, etc. So let's try and build a neural network. So we are not going to code this, we're just going to say what we think. Let's build the t-shirt sales neural network. We get data on t-shirt sales, then we decide on an algorithm. So we want to classify if it will be a top seller or not a top seller. So we just use classification. Then we train the model. So we train the model by adjusting the numbers and we learn how we adjust the numbers later. Then we can test the model on some data and we are done. So to train a model, there are two main things that we require: cost and gradient descent. Let's talk about both of these. So here's a plot, right? And as I told you, everything is a number. So let's say these are two numbers in our model. So these numbers are adjusted to get outputs. So this axis is one number, this axis is another number, and this is the plot. So this plot, as you can see, has one minimum, global minimum. So what this is basically the optimal state of your model. So what cost is this plot. So the state of your model, right? So how far is it from being at the best? So let's say my cost is very high. That means my model is far from being the best. If my cost is really low, my model is pretty close to being the best. Then gradient descent is just when you try and go down to the global minimum. Let's say my parameters over here start somewhere here and I want to come down. So I use gradient descent and I know the cost, right? So there's one global minimum on the cost plot. So what I want to do is come to this place. So now let's talk a little more about this cost and gradient descent with an example of house price prediction. So this is some data. Also, as a note, the x and y axis have been interchanged. So don't look at that. Think of independent variable as x and the dependent variable as y. Let's say that the independent variable is the size of a house in square feet and the dependent variable is the price. Let's say these are just some data points and what we are trying to do is fit a line through it. So how do you fit a line? You fit a line by using this equation. This is the equation for a line or a linear equation. Y is equal to mx plus b. So the two parameters in this are the m. So the m is a parameter and b is a parameter. B is the y-intercept and m is the slope. So let's say I take this point. This is the price. I want here. I come here. So let's use a pen tool. So I say this, right? So I take this point. So what my price will be somewhere here. But according to my model, the price will be somewhere here. So the price according to my model is a little different, right? Maybe let's say it's about 50,000, 50k different, right? So what this difference between things is called cost, right? So the difference is called cost. What you do is you take the cost function, which is just your real y. So yi means the real label y. So let's say we say the real label is x, let's just say it's a, and this thing is b. Okay, let's d. Okay, a and d. So yi just means the real value, which is a, and y hat is just this hat over here, this carrot shaped thing, is your predicted y. You subtract them, you square them, and you sum it for all i's. So every single row, every single row of data that you have, and then you take the average of it by dividing by m, and you divide it by 2m because it's easier. It becomes easier later to do calculations with this. Okay, but basically this is the equation, right? Now what the cost measures is how far these points are from the line. So let's say I have a line here all the way here. So all the points are so really far. So this line is not a good line, right? But this line is a much better line, the blue line. So that's what the cost measures, and that is what you are trying to get to over here, the global minimum, the best line. How do you run gradient descent? Gradient descent is just, so you just subtract w. So you just take w and subtract from it some learning rate. So this alpha over here is the learning rate. We'll talk about learning rate more. This is just the equation. We'll talk about learning rate more in the later videos. And then you take the cost and you take the derivative of the cost with respect to the weight and you see how much it changes. So if I change the weight, how much will my cost increase? And then you do the same thing with B. So after you're done with that, you'll eventually, after you run this for a lot of iterations, you'll eventually get to a optimal W and B. And that's when you'll get an optimal line to predict. So now let's say I have this line, right? I have this line which is M is equal to 2 and let's say B is equal to 3. And my X is, let's say I have, let's say 10,000 square feet. So it'll just be 10 times 2, which will be 20 plus 3. So it'll be 23, okay, and into 1,000, 23,000. So it will be 23,000. So the cost of the house will be 23,000. according to our model, right? So that is linear regression and gradient descent, and we've understood the cost and we've understood how a model reaches its best. So now let's just code a little bit. So here is a Colab notebook on linear regression. It's just one variable linear regression. So let's start. We'll start by importing NumPy and matplotlib. NumPy is just used for data, so matrices and tensors. Matplotlib is used to visualize the data. So xtrain, right? These are the size. This is the size of the house in thousands of square feet. And this is the price of the house in thousands of dollars. Okay. So when it's 0, it's 100. So I know this is wrong, but we just want to test it because the y-intercept should be 100, right? Close to 100. And 1, 300, 2, 400, 2.5, 900, 3, 1.12 million. And then we just, m is the length of xtrain. What m is over here is just the total number of rows or total number of data that points that we have. So we have 1, 2, 3, 4, 5. So m should be equal to 5. If we print 5, if we print out m over here, we get 5. So that just is the number of rows that we have. Let's plot this data. And as you can see, it's a scatter plot. And here it is. So as you can see, this is close to 100. This is 200. So this will be somewhere 100. This is our data. And if we try to plot this, this is what it looks like. Okay. So this is what our line looks like. Let's just go back to the scatter plot. And now let's think of our output. So to think of our model, for now, think of our model as just a function. So let's just think of our model as a function of a weight and a bias that results in an output. So this is compute model output. It takes a weight and a bias. What it does is it takes np.0's m. What this does is creates an array of five numbers, because remember, we have to predict for all of these 5 points, right? That's why we've used m. Then we just go for I in range m, fwb I. So remember, in computer science, it always starts at 0 in computers programming. So the first index will just be w, the weight, times xtrain I. Xtrain I is just the first value. Then 1 will be the second, third, fourth. So it'll just go on, right? It'll go on. And then we add the b. Then we return. After this, we return. So that will just give our predictions to us. Now this is another plot. So we're just going to plot our line right now with w0, b0. So this is our line with the y-intercept at 0. Now what we're going to do is write the cost function. So let's take a look at a cost function. This is cost function. So we take y, w and b. So we take w and b and we require y. What we also do is we go for I in range m. We know m, and for every data point in xtrain, what we do is we get the prediction, right, by doing w into xtrain I plus b. And then we do cost is equal to cost plus y hat minus y squared. So it's just the same thing. It doesn't really matter if you do y first, you'll still get the cost, right? So y hat minus y square or y minus y hat square. You add that to the cost because we have the summation, we have the sum operator, and then in the end we divide it by 2m. And then we return our total cost. So after this, we try to calculate the gradients. What do we mean by gradients? By gradients, what we mean is this part over here, the part where we calculate how much the cost changes for w and b. So there's an equation for this, and the equation is just grad w. So we start by saying 0, 0, and for every row, what we do is we calculate the predicted value and we subtract. So this is just the cost right now. For weights, what we do is we multiply it by the x train, and for b we don't do anything, and then we keep adding it to our initial 0 0, and then we divide it by m. Okay, let's run this. So that's to calculate this part. Now we just do run gradient descent. So we have the iterations we need to run it for, the gradient function, the learning rate, the weights, and the bias. So the weights and the bias is just from the function. Then we run it for the number of iterations. What we do is we get these gradients and we multiply it by learning rate and subtract it from w, and then we return it. So let's run this and let's try and find out our w and b. So we've found out our w and b, and here is our wb. So let's run this. Here's our plot. It's the best fit through this data, right? So this is a simple linear regression, and in the next video we'll be talking about logistic regression.